We are working with TypeScript. TypeScript is a subset of JavaScript, which is based upon JavaScript, but it has many different functionalities. By using TypeScript, we can see the errors while we are compiling the program. So on development stage, we can check the errors and correct them. We don't have to see them on during runtime, which we have to do while using just JavaScript. Also, TypeScript makes the code easier to write and understand. So for that, in our project here, we create .ts file, which is for TypeScript. Here we write a JavaScript code, and we can use additional functionalities of TypeScript that has different syntax, and that will create the corresponding JavaScript file here by writing this tsc and app.ts, the file name of the TypeScript file. So an index.html file will give JavaScript source. So this is like a compiler. We write the program here and it converts that into JavaScript, which we can then see on browser. We cannot view just TypeScript on the browser. So we install this light server, which can be used to refresh every time we update the file. It automatically refreshes the browser. And then we write npm start with node packages. So this will start this in the localhost server. So whatever, for example, we have this print statement here, console.log. So this gets converted into this JavaScript file, which we can see on the browser here on the console. So now we have the different types we have in JavaScript. They are also present in TypeScript. So we can use them, and then we can use the additional functionalities that TypeScript offers. So for example, in just JavaScript, we have a function add, and we pass two parameters here, n1 and n2, and then we use the function. For example, we pass two numbers here, and we print the result by using this function. So for example, we have this result n1 and n2. So this will add these two numbers in the console. But then if we write these as a string, so on just JavaScript, this will concatenate the string and give that as the result on the browser. So here we can use TypeScript, because in JavaScript we get that as a result. It does not produce an error, even though it should not be the case. So in JavaScript we can use an if statement here. For example, type of n1 and n2 should be a number. If they are not a number, then throw an error, incorrect input, else return the result, which is the addition of n1 and n2 if they are a number. So we can write this. So this will generate an error during runtime, but here we can use TypeScript instead of this to see the error during the development stage here. So we use colon and write the type here, number. So this is all the numbers, integer, float, etc. are just numbers in JavaScript. So we pass this, and then if we try to pass a string here, now this will give this error during this compilation stage, that it is not assignable to type number. because this is a string. So here we can correct the error that we get before running this program. This will still run the JavaScript file and this will still show the result on the console. But here we can see the error and we can correct this for running it. So this is the benefit of TypeScript. So we also have string type and boolean type. So these are the basic data types. So we pass another parameter. We give the type string. So we can pass a string here, and we also can use boolean here. For example, create a parameter show result and pass boolean. So then we can use this here. If we write an if statement here, if show result, so this if it is true, we console log this phrase, which is the string plus result. So this will pass this phrase result is and then pass the result n1 plus n2. Else it will just print the result. So we can use boolean and string like this also. And also if we just write this statement here, for example phrase plus n1 plus n2, we want to add add to get the result and write the statement a result is in that. So since this is a string, so this will concatenate n1 and n2 as also a string. So we want to add the numbers like for example 5 and 2.8, we want to get 7.8 as the correct result. We can create a constant before the if statement. We can use that here. So these are the basic data types that we can use. Now we also have objects that we can pass here. Also we have inference. So TypeScript uh, infers this by itself, that what is the type of a particular parameter. For example, we have this constant we create. So since this is a constant, its value cannot be changed after that. So this we can see the value written here. But if we just write this as a variable by using let, we see that this infers this as a number. So we don't have to specify that here like this if it's a number. And also for string, we can see that this infers that as a string. So after that, if we try to pass a number in this, so this will generate an error here since this should be a string. We don't have to write this here. If we're using TypeScript, we can just see that it infers by itself. So this is the benefit of TypeScript. Now we can have other types like object. So if we have this object here, we can explicitly tell the type. So if we just write constant person and then object, and then if we try to get this, for example, person dot name, that will generate an error. So if we want to explicitly write the type of an object, we will have to specify the type of every variable inside of that object. It infers by itself these, but we can write the types declare the types like this also. Inside of this object, name, string, age, number, and here we can also have this array type that we can specify. And we can also have nested objects inside of this like this. Now we can see this person dot name, so it will display this as we specified the type of all. Then we have this array type also. So we pass an array here inside this object. So we can specify the type by writing this string and then array. So this will tell that we have strings inside of this array. So we have these two strings. So this will infer that these are strings. Then we can see the hobbies like this. For example, we use for loop inside of this person dot hobbies, and here we use this to uppercase or any function that we can use on a string. So this will automatically infer this hobby as string since it is inside of this hobbies array. So since we specified this as a array of strings, so TypeScript infers individual strings out of this, and we can use this option, and we can use this operations that we can perform on strings. We can use on this also. But for example, we have this dot map operation. This is to be performed on an array. So this will give an error here since hobby is a string inside of this hobbies array. So and this array can be of any number of strings here. But if we just write an array here without writing this string, so we can also pass numbers or boolean inside of this array since we have not specified it. Now we have another data type, which is not a type that we have in JavaScript, but we can use that in TypeScript is tuple. So in tuple, we have to specify the number of variables that we can have inside of an array and also their types. So for example, we have this role where we specify this, we pass an array to specify the type, and inside that we write first number and then string. So this restricts this array now. We can only pass a number and string. There is two variables inside of this, two elements. So this creates a tuple here by using TypeScript. So for example, we write this to and author role here. So now when we have these operations, for example, to change the first element, so this will give an error now since it cannot be changed now with this, and we cannot add three elements here like this also. So this will give an error. So we can use TypeScript like this to restrict an array. But we can use push operation, load push. This will push this admin string inside of this tuple. We can use this dot push operation on a tuple. We cannot use these other operations. Another type that is not present in JavaScript, but we can use with TypeScript is enum. So enum converts whatever we write here, whatever we pass here as a number starting with 0, 1, 2, and it increments like this. Pass the label like this. So for example, we have a role variable here. Then we can write this and we want to use that later. And if we forget the name of the string, so that can be a problem here. For example, if person.role, we want to pass the string name here, and we can write this wrong here. If we don't know exactly what string we passed here, we can use string like this, but that will not be efficient. So for that, we can use this enum to pass this admin, read only, and author as roles here. Then we have this curly braces. This is the syntax for it. So we pass this. Here we can role. We can write this role dot, which is the name here. So this will generate automatically. We can write admin, for example, and here we will get to choose again. So this becomes easy, and we print, for example, print this statement if the role is author. It necessarily doesn't have to be 0, 1, 2, 3 like numbers like incremented like this. We can choose to write something else also. We can pass a string also here. So this is another type we can use in TypeScript that is not present in JavaScript. We can use another type which is called union. So for example, we want to have different types that we can use for a variable. For example, we pass this. So we create a function and input one and input two, we pass it like this here. It can be a number or a string. You can have multiple here also, like boolean for example. So here we have number or string. So whatever we pass this number or string, it will not give an error. Since we can have both the number and string here, we can use this sign here to use this union to make the union. So we can use this here also. Use the union type here to make runtime check, type check. So if type of input one and input two, look and operator we write as number. So it prints result as input one and input two. Else it uh, force converts it to a string and returns the result. So this will be the same calculation as before, but we can be more flexible with union types like this. If we have different logic inside of this function, so we can write like this. Then we have literal types, which is the exact what we have here. So it will be the exact value that we write here. For example, we give the 2.8 here. So this will infer this as this exact value because this is a constant. So this is the literal type of this. Now if we want, for example, we create another, we create another parameter here. We pass another parameter in this function. Where we have this as number or as text. We create a union and pass it here. And in the result here, we pass this. For example, when we have the number here, we want to print the result as number, so we can write this here to see. And even if that is a string, we want to do a forced conversion here to print that as a number still. So for this, we can here write it like this. If the result conversion as number, we want to print the result in input 1 and input 2 with plus. So this will print that as number, else convert that to string. So we can use this another parameter here to do a force conversion. If it is a number, so this plus that we use here, it will make it that these two add up as 56. So this will print this, that first one will be 56 because we are adding just adding two numbers, and here it is a string, but still we do the force conversion here and print 56. And third is the concatenation of both the strings when we have this as text. Now we can also create some custom types by using this type. We write type and give the name, the type that we want to create. So we can use this to make the code cleaner. So we can just write this, and for example, we pass a union that we are using number and string, so that we can use this combinable here. And as number as text in uh, these string types that we had, so we can use this here. So we don't have to write the complete union. We can use this for any other types also. So we can just use that name here whenever we want to use those.